So now we consider problem 4.7, where we look at a mixture model where we assume that the variable w is gamma distributed with parameter alpha and theta, and where we assume that x given w is equal to w, it has the distribution gamma with parameters beta and w. So this is kind of just a heuristic notation that you shouldn't take too seriously, that we'll just use just to write up the facts. So now we're asked to find the unconditional density of f, the unconditional density of x. So just a couple of freshening up remarks here. You guys probably remember that we have something called the simultaneous density of x and w. So the way that this relates to the conditional densities is that the simultaneous density is equal to the conditional density of x given w, evaluated in little x given little w, multiplied by the density of w. And now this formula for the densities stems from the rather intuitive fact that if you have, for example, the intersection of two events, then the probability of that is equal to the probability of one event given the other multiplied by the probability of the event you condition on. So by using this on distribution functions and then differentiating the distribution function, we will arrive at something like this thing here. Now what we want to do now is we actually want to find the conditional distribution, the unconditional density of x, right? So we're actually wishing to find this thing here. But then the only thing that we need to remember is this is just, I don't know why I'm writing something else than what I want to say. We want to find the density of x, evaluated in x, and this is just equal to the integral of the simultaneous density, where we get rid of the variable we don't want by integrating with respect to it as such. And in turn, we can replace this simultaneous density with the conditional densities. So with the conditional density of x given w multiplied by the density of w. And here then we have an expression for the density of x in terms of the conditional density of x given w, which is given as the gamma density with parameters beta and w evaluated in x, and then we have the density for w, which is also given as a gamma density, evaluated in w with parameters alpha and theta. Okay, so now we're actually ready to get started with the calculations. Just before we go on with the calculations, I would like to remind you guys of the fact that this formula is actually also to be found on page 47 in the section on mixtures. So whenever we have to do with mixtures, basically what we're looking at is a setup where we say we know the distribution of one thing, and given some outcome of that that thing, we know the distribution of something else. Now, that is only something we know given an outcome of that thing. And now I'm just talking about things. So the thing that we will do now is just in this video, and in the next video, we will talk a little bit about some of the intuition behind mixtures and why they can be pretty practical to have in different situations.